Hey folks, we are in the Austrian Alps. That's a glacier right there. You clearly see the ice. Actually the grey stuff is the ice, the white stuff you see is the snow on top of the ice. And the ice is grey because there are little pieces of debris and stones and so on in there. So we're quite high up in the mountains. It's the month of August and yet it's relatively cold. We had snow all day yesterday with our students. I figured it was a really cool place to show you a little bit of what we're doing here and a cool find that I was just really happy to see. So one of the things that we're doing is we are describing soils at different distances from the glacier. And with a retreating glacier, what that means is that with increasing distance, the age of a soil increases as well. This soil is very close to the glacier, and so it's very young, in the order of 4 to 5 years. That's how quickly this glacier is currently retreating. It's very sad, actually. What the boxes are doing is they contain very sensitive carbon dioxide sensors, and every 30 seconds they measure the CO2 concentration in the boxes. And if that concentration changes, it has to be because the soil is either taking up CO2 from this little amount of atmosphere in the box or giving back CO2 to the atmosphere. Mostly we find that soils, and especially vegetated soils of course, are drawing down CO2 from the atmosphere into the soil, which is something we like. Less CO2 in the atmosphere is a good thing. And of course this is faster with vegetation because that is the photosynthesis effect. We measure that for about 10 minutes in every location, and then we move on. And because we're scientists, we replicate. Because we don't want one coincidental high rate or one coincidentally low rate. We want to be able to average things out. So what we just found in this particular soil, as you can see, the area here is an area of a very small localized area of deposition. If you come a little bit closer, you can see something super cool. Very fine sediment. You can see it is saturated because it's squishy like a pudding. So let me cut out a little piece of the pudding for you. Here we go. Usually I can get this out in one piece. Here we go. Now if we open this up, let me see if I don't want to get too muddy myself. If we open this up, what we see is layering, hopefully. Right here, we see layering. Every single layer is an event of deposition. It's not a year per se, it's one event of deposition. Millimeter level layers. What I wanted to show you is not super clear here. Maybe it's super clear here. Not so much either. Let's grab the previous one. What you see here super nicely is the layers. So this was the surface, this side. Let me turn it around for you. Here's the surface. You see the events of deposition, beautiful tiny layers. And then you see this crazy stuff over here. You see that sort of wishy-washy, chaotic sort of destruction of the structure, although you still see the layers. That is the effect of the water in this deposit freezing. Of course, this is a very cold place. All winter long it freezes. Sometimes in summer it freezes. And that causes this this destruction of the layering. It's called cryoturbation or frost turning, and that's the sort of the special find that we saw just now together here. What it means is that we have some sort of a small depositionary wetland. Soils are forming very slowly because they've only had 5 years of time. One of the processes that's playing out here is cryoturbation. Others will start as well, weathering of the material. At some point plants will colonize this. And before you know it, we have a whole new ecosystem in this place that up until 5 years ago was a glacier. Should you come here? Yes, you should. See you later.